Yeah. Give us some views on our channel so we feel better about ourselves. Okay, so now we just have some line segments. So it tells us segment AC measures 10 1/4 units, segment AB measures 4 3/7. Find BC. So we know this entire thing is 10 1/4, right? So this is 10 1/4. Oh my, I don't like how it doesn't draw where this cursor is. Okay, we'll use a different color. We know that AB measures 4 3/7. So right here, we have 4 3/7, right? So what am I going to do if I want to find BC? Yep. Subtract, perfect, because we have the whole number. We have this little section right here. So we're going to want to subtract to find BC. So we're going to do 10 1/4 minus 4 3/7. Perfect. So we have this other problem again. We don't have this common denominator. So this time, someone tell me what my common denominator is going to be. Anybody else? Anybody else? Yeah, that. 28. Perfect. So we can do it on our heads this time since I think you guys are experts. So we're still going to have 10, but then we're going to want to multiply this guy by 7 over 7, right? We're going to have 7 over 28. Perfect. Minus 4. And we're going to multiply this guy by 4 over 4. So we're going to have 12 over 28. Uh-oh, we have another problem. Anybody see what the problem is? Yep. Perfect. Well, you can, but a negative wouldn't really help us much in this situation. So that is absolutely right. So we sort of want to do like a borrowing kind of situation, sort of like when you're doing regular subtraction. So when we borrow, we're going to take 1 away from this 10. So it's going to become 9. And then we get to add 28 parts because we're adding a whole 28 over 28. So we're going to do 28 plus 7, which gives us 35.
You guys, you do need to show this work, all right? You got to show that you did that. Make sure you do.
So just do 28 plus 7 on the top.
No, like what you did is perfect.
Okay.
Some people skip the 35 part.
Okay.
Don't skip that. Show that one.
Yeah. And we can keep this guy the same over here. Now we can subtract the wholes from the whole and the part from the part. So 9 minus 4 is going to give us 5. 35 minus 12 gives us 23 over 28. 23 over 28 does not reduce, so that's going to be our final answer.
So question for you guys. How many of you guys would have made these improper and then done common denominators? Okay? You can. It's actually harder because the numbers are huge. Okay? So you can keep a mix when you add and subtract. Can you keep a mix when you multiply and divide? No. All right.
Okay. I know. So for the first, we won't always do this. The first. Okay. So these are just some sort of, I guess, definition kind of stuff that I feel like you guys probably already know. So intersecting lines are just two lines, straight lines that are crossing each other, just like it sounds. Parallel lines are two lines that never touch, so they just keep on going forever. They never touch. Just draw little pictures of those in your notes.
Yeah, make sure you write all this down, guys.
Yeah. You will see this stuff again. The lines either have to be intersecting or parallel. They can't be both. Okay, perfect. So now we have some review of angles. So this is also, again, some review I would expect. So right angles are angles that cross perpendicularly. And usually you guys probably recognize it with this little box. So right angles are 90 degrees. And when you have one like this, they're all 90 degrees, right? They're all square angles. Just do that. And they always measure 90 degrees. Okay. The straight angle is actually, we're talking this whole angle right here. So it's just a straight line. The measure of a straight line is 180 degrees. Okay, and then next over here we have obtuse and acute angles. So obtuse angles are greater than 90 degrees. You can see from this picture, it's bigger than a right angle, but it's not fully a straight angle. An acute angle is less than 90 degrees. And probably just draw that whole picture right there would be helpful. And then down here we just have one right angle and then 180 degrees in a straight angle, which is just what we did above.
Anybody know another name for a straight angle like that? What's wrong? We got the two angles that make 180. What we call this? No. Supplementary. Should we call it supplementary? Complementary.
So then for that, if we make this angle x and we make this angle y, they are yeah. There's 360 degrees in a circle. So if we start here, we make our way all the way around, that's 360 degrees. I hit that. Okay, polygons. Closed flat geometric figures whose sides are line segments. So basically, shapes. They have to have straight edges though, so we would think about this, I would probably call this a shape, but it's not a polygon because it doesn't have straight edges. So these are not examples, and then I'll go down a little bit. Those are examples. So I'm going to start labeling some of these guys. I'm doing my best to write. Might actually sit down for this. I promise I'll get better. Okay, so this is a triangle. We all know that, I hope. I just can't. Rome. A square, right? Can anybody tell me what the next one is? 5 sides? Pentagon, perfect. You guys are going to become prefix masters. Pentagon. How about 6? Nice. Hexagon. 7. Heptagon. Yep, I heard it somewhere in the front. Heptagon. And then 8. Octagon. Perfect. Like a stop sign. All right, now we have some sort of weird ones that are hard to even draw, but they still have names. How about 9? It's actually nonagon. 10 sides? Nice. 9 must have just been hard to remember. 11? That one's really weird. It's an undecagon. Do you know how to say that, Mrs. Weber? Undecagon. Okay. I challenge you guys to try and draw a shape with 11 sides. So it would be almost look like a circle, I think. 12 sides. How about that? Dope. Oh, you guys are like every other. Nice. I'm impressed, actually. Very impressed. And then for insides, we just call it an n-gon. So anything bigger than that, didn't bother to make names.
One thing, you guys, for the square, they're not always all squares, right? What is any 4-sided figure called? Yeah. Good. So you might want to put quadrilateral underneath there, because a square is a more specific quadrilateral, but any 4-sided figure is quadrilateral.
I got confident with the ones that I knew. Okay. Everyone got that? Take that as a yes. Okay. So concave and convex, this is just sort of how it's shaped, I guess. I always remember concave, they look like they have a little cave in them. So it's one that has like an inward angle, or an angle that's greater than 100, or greater than 180 on the inside. So this angle is greater than 180. This one's concave. So these ones I probably would draw an example. It doesn't have to be this exact same one, but draw one that has that angle on it. And then this one is convex, because it has all of its sides are sticking out.
So if you can connect any two vertices and it's inside of the figure, so like connect those two, then it's concave. All right? Like any two vertices and there's shapes inside of it, then you have a concave polygon.
So like we can connect. We can connect those. But here, we can't connect these. It goes on the outside of the shape. Regular polygons. Can anyone tell me what an equilateral polygon is? What does that mean? Yep, what's your name in the back? Ella? Perfect. So this is a good example. When I wrote square earlier, a square is an equilateral and equal angular, I guess. Quadrilateral. That was complicated. How about equiangular? Equiangular means all the angles are the same measure.
So in order for it to be regular, it has to be both equilateral and equiangular. To be regular. Right?
So this one looks like it's totally regular. We have all of these angles are the same. And all the sides are also the same. These little marks just mean that they're all the same. Next. Okay, so these are some different types of triangles. What's this guy? It's got a right angle in the corner, right? 90 degrees. Yep. Scalene. Not quite. There is a scalene triangle on this page.
Actually, it looks scalene, but yeah, it's right for that one. We're not 100% sure if that's scalene unless they tell us it's got different sides. But it's definitely right.
Right triangle. How about this guy? Obtuse. Perfect. So we have this one. This guy has this angle right here. That's bigger than 90 degrees. So it gives us an obtuse. So this angle is greater than 90 degrees. So it's one angle bigger than or greater than 90 degrees. How about this guy? Cute. I heard it somewhere over in the distance. Perfect. A cute triangle. And this one just has no angles that are greater than 90 degrees. Right? Greater than 90 degrees. Okay, so So these are sort of the ones that we worry about the angles, and then these ones below are when we worry about the sides. So when you said scalene, that is going to be this guy, right? Scalene means none of the sides have the same length. So we'll start with that guy since we had the right answer earlier. Scalene triangle. I gotta just get used to where it starts to write. Anyway, okay, how about this middle guy right here? So it has two sides that are the same length. Yep. Perfect. Triangle. And then one other thing actually happens with isosceles triangles. When they have these two sides that are the same, these angles below will also always be equal. So if you have these angles that are equal, it means that these sides above them have to be equal. And if you have the sides that are equal, it means the angles below them also have to be equal. And then this last one is just an equilateral triangle. All.
Yep, and if it's equilateral, you guys, if three sides are the same, that means that two sides are the same. So equilateral triangles are actually always isosceles too. You guys know that? Anybody know what the angles inside that triangle always are? Yeah. Yep, always 60, because they're all equal. All the sides are equal, all the angles are equal.
Looks like everyone's done writing. Okay, so the sum of the three angles of a triangle is 180. So you kind of had to use that to know that all those angles in that other triangle were 60 degrees. So always inside a triangle, it's going to be 180 degrees. So if we want to figure out what x is, right, this guy right here, what can we do to figure out, to solve for x? Bethany?
You add 130 degrees plus 30 degrees, and then you subtract that from 130.
Exactly. So the way that we're going to write it, though, so this rule that we have, which you guys might want to box or star or whatever you want to do, just so you know that it's there, is that they always sum to 180. So the way that we're going to solve it is say x plus 130 plus 30 equals 180. So this is telling us that all of the angles on the inside of the triangle are going to equal 180. So whenever you guys do this on your homework, you guys will see these type of problems for a while. I always want you to do it all of the angles on the left and then equals 180. And then do we have to do a reason for that or no? Okay. So now we just have x plus 160 equals 180. Nope. Okay. So we want to show all of our steps. So minus 160. So we want to get rid of the addition. We do the subtraction from both sides. Subtract, and I'm just going to go down below here. We'll have x equals 20 degrees. And we're not really particular if you show the degrees in your work, but for your final answer, you should always have a degree sign on there. It's kind of like units. I know in science and math, we're pretty particular about units. So in your final answer, just put that little degree circle on it. Everybody good? Okay, so find x and y. So now we have an isosceles triangle, right? Because we have these guys. So what did I tell you earlier about isosceles triangles, about these angles? Yeah. Perfect. So since we have these sides are the same, the angles below them are always going to be equal. So that tells us right away that we have x equals 50 degrees. And we want to put a reason for that, so we just say IT.
IT means isosceles triangle.
So whenever we say something like that, you always want to give a reason. Isosceles triangle. So I'm writing that all out, but when you guys are doing this in your homework and stuff, if you just put IT, we're okay with that, just the abbreviation. As long as you know what the abbreviation means. So we're allowed to do that because we know it's an isosceles triangle. Okay, so now we want to find y, so we're going to do what we did on the last one. So we have x plus 50, plus y equals 180. We know from up here that x is 50, so 50 plus 50 plus y equals 180, right? And then we would subtract over 100, right, because 50 plus 50 is 100. And then we would get y equals 80 degrees. Yeah. Definitely always start with the formula and always give us reasons too. Find x and y. So we know these are the same because we have an isosceles triangle, right? So they're 8 and 8. So instead of giving us the lines on this one, they gave us the actual measure of the sides, which tells us that x and y have to be equal because it's an isosceles triangle. So we can say x equals y, and then this time I'll do the abbreviation, IT. And then we know that x plus y plus 110 equals 180. So x plus y plus 110 equals 180. And x equals y, so we can just change this to 2x, because we have x plus x if we do some substitution. Equals 180. Now we can subtract 110 from both sides. We get 2x equals 70, right? Because 180 minus 110. And then we divide by 2. To get x equals 35 degrees. And then from above we know x equals y. So we also know that y equals 35 degrees. We did all of that just from knowing that the sum and the inside is 180 and that x equals y because it's an isosceles triangle. Should we...
You right arrow? Yeah, there you go.
Label the following. Should we do that?
Yeah.
Okay. So, can anybody tell me what this first quadrilateral is called technically? Bethany?
Close?
Close. We do have a rhombus.
It's a rhombus, so there's more general words.
In the front? Yeah, perfect.
Draw these pictures, you guys. Parallelogram. Means that two sets are parallel, right? You have parallel sides here, parallel sides.
Okay, how about the second guy over? Yep. Perfect. And then this guy. So it's pretty easy. Don't make it too complicated yet. Yeah. It has all right angles. Rectangle. How about this guy? Someone said it earlier. Yep. Yeah. Rhombus. Now the last one. Yep. Yeah, that's a square. So the rhombus has all equal sides, but it doesn't have to have equal angles. So it's like a tilted square, kind of. A square is also a rhombus, though. Square, rectangle, trapezoid is tilted up, and a parallelogram just has the equal sides opposite each other. And that will do it. So you guys are